Hello again, ladies and gentlemen. Today we're going to talk about half-lives. Now, if you have taken pre-calculus, this will look familiar, and in foundations, we've also started talking about exponential equations. So we're going to start off. These are called doodle notes. Feel free to color in whatever you can. Studies have shown that doodle notes are a good way to free up part of the brain. So we're going to start with some graphing. So we're going to plot the percent of the original mass remaining after the number of half-lives. So here's my percent, and here's my half-lives. Okay, so if we start, we're going to start at 100%. Now, the definition of a half-life, that's the average amount of time it takes for a radioactive substance to decay to half its original mass. So this means after one half-life, I should have 50%. After two half-lives, I should have 25%. After three half-lives, I should have 12.5%. After four half-lives, I should have a little bit more than 6%. After five, closer to 3%, and so on, getting closer and closer and closer and closer to zero without actually getting to zero. And I'll do my best to join this with a smooth curve. And it'll look like an exponential graph. As you can see right there. Now, using this graph, we could actually estimate the number of half-lives it takes for it to get to 40% of its original mass. All I have to do is look at the 40. The line is right there, and it looks like it's about 1.3 half-lives. If I want 10%, I'm going to go to about there, which looks like about 3.3 half-lives. So that's how we can use the graph to estimate. And of course, if you want to use Desmos to build a graph or any other graphing technology, feel free. Now we could also use a table. So osmium 183 has a half-life of 12 hours. So every 12 hours, it should be half. So if we start off with 180 grams, in 12 hours, we should have 90 grams. In 24 hours, 45 grams. In 36 hours, 22.5 grams. In 48 hours, 11.25 grams. And in 60 hours, 625 grams, if I did that correctly. Okay. And there we go. And finally, we can use the equation. Here's my equation. All right, so this is my amount. This is my starting amount. Here's my base of a half. And this is my time. And this is how long my half-life is. Now, time and half-life should have the same units. So we're going to see here, a half-life of cesium is 32.1 hours. So H is 32.1 hours. If a 65-gram sample, so I started off with 65 grams, and it takes a time of 56.3 hours. So my units for time and half-life are the same. That's perfect. We want to know how much cesium 129 should arrive. So I just have to substitute the values into the equation, and I should get a value of 19.27, or approximately 19.3 grams. Since everything was to one decimal place, figured I would do the same with that. And here's your practice. All right, if there's any questions, feel free to get in touch with me as soon as you can. Thank you very much. Bye.